You ever look at a handful of dirt and wonder what's really in it? It might seem like just a bunch of tiny particles, but there's a lot more going on than meets the eye. Each particle has a story to tell, and understanding these stories is crucial for many industries. For instance, in construction, the size and distribution of these particles can make or break a project. Imagine trying to build a skyscraper on a foundation of sand. Without knowing the exact composition of the soil, you're taking a huge risk. Turns out knowing the exact size of particles in a material is a big deal in a lot of industries, especially construction. Engineers and builders rely on this information to ensure the stability and durability of their structures. It's not just about piling up materials, it's about understanding what those materials are made of. That's where sieve analysis comes in. This method has been a cornerstone in materials science for decades. By shaking a sample through a series of sieves, each with different sized openings, we can separate and measure the particles. It's a simple test that tells you the size distribution of granular materials. But don't let its simplicity fool you. The data it provides is invaluable. From soil and sand to gravel and crushed rock, sieve analysis helps us understand the composition of these materials in detail. Think of it like using a strainer to separate the lumps from flour in your grandma's kitchen. Just as you wouldn't want lumps in your cake, you don't want inconsistencies in your construction materials. But instead of flour, we're talking about soil, sand, gravel, or even crushed rock. Each type of material has its own unique properties and uses, and knowing their particle size distribution is key to using them effectively. This isn't just about baking a cake, it's about building a solid foundation. Whether you're constructing a road, a bridge, or a building, the quality of your materials will determine the longevity and safety of your project. Knowing the particle size is key for mixing concrete, making asphalt, and even compacting the ground before you lay a single brick. Each of these processes requires a specific particle size distribution to achieve the desired strength and durability. Too much fine stuff and your mix might crack. Fine particles can fill the gaps between larger particles, but if there are too many, they can weaken the overall structure. Too much coarse material and it won't bind properly. Coarse particles provide strength, but without enough fine material to fill the gaps, the mix can become unstable. Sieve analysis takes the guesswork out and ensures a quality product. By providing a clear picture of particle size distribution, it helps engineers and builders make informed decisions. This leads to safer, more reliable structures, and ultimately, a better built environment for all of us. Doing a sieve analysis ain't rocket science, but you do need the right tools for the job. The process involves separating particles based on size, and for that, precision and accuracy are paramount. Let's walk through the essential equipment you'll need to get started. First up, you've got your sieves. These are the backbone of your analysis. These are basically stacked containers with different sized mesh screens at the bottom. Each sieve has a specific mesh size that allows particles of a certain size to pass through while retaining larger particles. You'll need a range of sizes to get a good distribution curve. This helps in understanding the particle size distribution of your sample, which is crucial for various applications, from construction materials to pharmaceuticals. Then you'll need a balance to weigh your samples. This isn't just any scale. It needs to be highly accurate to ensure your measurements are precise. Accuracy is key here, so don't skimp on a cheap scale. A good balance will give you the confidence that your sample weights are correct, which is fundamental for reliable results. A sieve shaker is also helpful, especially if you're dealing with larger samples. This machine automates the shaking process, ensuring consistent and repeatable results. It does the heavy lifting for you, shaking the sieves to separate the particles. This not only saves time, but also reduces the potential for human error. Finally, you'll need some basic lab equipment like a brush, pan, and containers to collect and weigh your samples. These tools might seem simple, but they are essential for handling and transferring your samples without loss. Nothing fancy, just the essentials. With the right tools and a bit of know-how, you'll be well on your way to conducting effective and accurate sieve analyses. Before you start shaking things up, you've got to prep your sample. First, make sure it's dry. Wet material will clump together and mess with your results. Once it's dry, you'll need to weigh out a representative sample. The amount will depend on the material and the size of your sieves, but it's important to get a good cross-section of the material you're testing. Once you've got your sample weighed out, it's time to break out the sieves. Now comes the fun part. Arrange your sieves from largest mesh size at the top to smallest at the bottom. The idea is for the finer particles to filter down through the stack. Pour your prepped sample into the top sieve and put the lid on. Now it's time to let the sieve shaker do its thing. The shaking action helps the particles find their way through the mesh, separating them by size. The amount of shaking time will depend on the material and the size of the sample, but you want to make sure everything has had a chance to settle. Section 5. Weighing in, recording your findings. Once the shaking stops, carefully lift off the top sieve. You should see some material retained on the mesh and some that's passed through to the sieve below. Carefully weigh the material retained on each sieve and record the weight in a table. Do this for each sieve in the stack, working your way down from top to bottom. The last sieve in the stack should contain the finest material that passed through all the other sieves. Don't forget to weigh this as well. Section 6. Making sense of the numbers, interpreting the results. Now that you've got all your weights recorded, it's time to crunch some numbers. The goal is to figure out the percentage of material that passed through each sieve. To do this, you'll divide the weight retained on each sieve by the total weight of the original sample and multiply by 100. This will give you the percentage of material that's finer than that particular sieve size. You can then plot these percentages on a graph with sieve size on the x-axis and percent passing on the y-axis. This will give you a visual representation of the particle size distribution, known as a grain size distribution curve. Each of these applications requires a specific particle size distribution to perform optimally. Involved in making sure everything is built to last. Sieve Analysis is just one of the many tools that help make that possible. Section 8. Quality control through Sieve Analysis. In the construction world, quality control is everything. Sieve Analysis is a simple yet powerful tool for ensuring that the material you're using meet the required specifications. By regularly testing samples, you can catch problems early on and avoid costly mistakes down the road. This is especially important for large projects where even small variations in material quality can have a big impact on the final product. Section 9. Wrapping it up. The importance of sieve analysis. At the end of the day, sieve analysis is all about getting the right material for that job. It's a simple test with big implications for the quality and durability of our built environment. So the next time you see a construction site, remember the humble sieve. It may not be the most glamorous tool in the box, but it plays a vital role in ensuring that our buildings, roads and bridges are built to last.